The ultimate footprint for the world's most critical data infrastructure won't be terrestrial at all.
NVIDIA didn't just announce earthly servers. They unveiled the Vera Rubin Space One module.
It sounds like sci-fi, but it's real. They are literally building orbital data centers.
Because when you look at the thermal dynamics of a modern inference data center on Earth, you quickly realize we are just maxing out the physical limitations of our local environment.
Oh, absolutely. I mean, a single massive data center today requires the electrical equivalent of a small city just to power the chips.
And millions of gallons of water to cool them. The grid infrastructure in regions like, Northern Virginia or the Pacific Northwest, it simply cannot support the $1 trillion of new silicon NVIDIA is about to deploy.
The earthly real estate that has both high-capacity fiber optics and massive untapped water and power reserves, it's effectively gone.
It's totally tapped out.
So why is thermal management in orbit actually harder than on Earth?
Heat transfer requires a medium.
Right.
On Earth, we use convection. The server gets hot, the air around the server gets hot, fans blow that hot air away, and cooler air replaces it.
Or we use liquid cooling, where water absorbs the heat and carries it to a chilling tower.
But space is a vacuum. There's no air, there's no water, there is absolutely nothing to absorb and carry the heat away. The only way to cool a machine in a vacuum is through thermal radiation.
Meaning the server has to literally emit its heat as infrared light, just radiating it away into the void.
And relying purely on the Stefan Boltzmann law of thermal radiation is incredibly inefficient compared to earthly convection.
So you have to build these massive, sprawling radiator fins just to maximize the surface area.
And furthermore, while deep space is cold, if your satellite happens to be facing the sun, the solar radiation hitting your equipment will boil it instantly. So it's an engineering nightmare of extreme temperature differentials.
So if the thermal engineering is that much of a nightmare and the launch costs are astronomical, why are we doing this?
But because what space lacks in convective cooling, it makes up for in two critical, inexhaustible resources:
Which are?
absolute, unlimited real estate and unhindered, continuous solar energy. If you can solve the radiative cooling engineering, you have access to a 247 solar power source that is never filtered by clouds or an atmosphere. And when you contextualize an acquisition of $1.25 trillion alongside the deployment of 1 million orbital compute nodes, the System 2 structural truth becomes completely unavoidable.
The ultimate footprint for the world's most critical data infrastructure won't be terrestrial at all.
No. The inference engines of the future, the systems dictating global financial flows, logistics, corporate intelligence, they are moving to the ultimate high ground.